Imagine giant fields filled with photovoltaic solar panels soaking up rays. The best spots to put such panels are obviously sunny with little rain, but such places often come with lots of dust, and the panels have to stay dust-free. Just a seventh of an ounce of dust per square yard of panel can decrease solar power conversion by 40%, and panels in Arizona might get covered with 4 times that much dust each month. Cleaning the panels conventionally uses precious water, so researchers are turning to dust cleaning technology developed for one of the driest, dustiest locations possible, Mars. The work was reported at the National Meeting of the American Chemical Society. An electrically sensitive transparent material is deposited on glass or a plastic sheet that covers the panel. Sensors monitor the dust levels. Once the dust reaches a specified level, the system reacts and produces a charge, with electricity generated by the panel. The charge creates a wave over the material's surface that physically lifts the dust and tosses it over the edges. The system gets about 90% of the dust in a couple of minutes, so the panels can go back to soaking up rays.
Obviously, birds sing. But mice? That's a mouse song. Researchers have known about these high-pitched, squeaky songs for years, but they only recently discovered that mice can learn the songs of other mice. Such vocal learning is a rarity among animals. We know of only 3 kinds of birds: parrots, hummingbirds, and songbirds, and some mammals, like humans, whales, dolphins, sea lions, bats, and elephants, that have demonstrated the ability to learn the vocal patterns of other animals. That is, until now. Scientists at Duke University observed that when 2 male mice of different lineages were kept together, the animals gradually learned to match the pitch of their songs to one another. And when the researchers examined the mice, they found that the rodents can also form the correct brain-to-vocal cord connections to control the sounds they make. The research is published in the journal PLOS One. The mouse songs are admittedly primitive, but the findings left scientists on a high note.
Talk about your vicious cycles. A new study finds that belly fat could be making you hungrier, which would lead to more belly fat. The research was performed at the University of Western Ontario. The culprit is a hormone called neuropeptide Y, or NPY. It was thought that only the brain produced this hormone, but no, your belly fat can make it too. So NPY produced in the brain initially makes you eat more and gain weight around your middle, and then that fat makes more NPY, which makes you eat more. Now, fat cells can't reproduce themselves, but the release of NPY can stimulate the reproduction of cells that are precursors to fat cells. So the result is the same, more and more fat cells. The researchers next want to come up with a way to easily detect the presence of the hormone and to turn it off. The hope is to identify and treat those people at greatest risk for becoming abdominally obese, because it would be easier to prevent obesity than to treat the many diseases that obesity can lead to.
In 2011, a 28-state outbreak of listeria from cantaloupes infected 147 people, and 33 of them died. After that, many Americans evidently thought twice about bringing one of the melons home. Cantaloupe consumption dropped by half after the infections. But paying closer attention to the ecology of our fields, like tracking when they've been rained on, could be a step toward beating bacteria and preventing that sort of food poisoning. So says a study in the journal Applied and Environmental Microbiology. Researchers monitored spinach fields in New York State, both before and after irrigation and rain, and they found that levels of listeria bacteria in the soil spiked in the 24 hours after water hit the field, up to 25 times the levels that were present a week after the rain. The scientists cite two factors. Listeria is exceedingly common in the environment, from the soils of national parks to, yes, irrigation water. So listeria could be getting dumped directly on fields during irrigation. But rain also creates more favorable conditions for a bacterial bloom, and that holds for any type of bacteria present in the soil, the researchers say, whether Salmonella, E. coli, or the listeria studied here. The lesson for farmers, they say, hold off on harvesting after rains or watering. And if you can't wait, consider rinsing the fruits or veggies after they come off the field. The researchers are developing a web app that'll help farmers forecast bacterial loads in their fields to make sure that the only thing that makes it farm to table is your food and not infections.
July's coming. It's a time to fire up the barbecue, hit the beaches, and watch the fireworks. It's definitely not a time to be in the hospital, because fatal medical errors peak in July, an increase that happens to coincide with the annual arrival of new medical residents. That's according to a study in the Journal of General Internal Medicine. Could new docs really be deadly? That's what sociologists at the University of California, San Diego were wondering. They examined almost 250,000 death certificates issued in the U.S. between 1979 and 2006. And they focused on those that showed a mistake with medication as the primary cause of death. They then recorded the month in which the error was made and whether the incident occurred in a county with teaching hospitals. Turned out that fatal medication errors spiked only in July, which is when new residents hit the wards, and this peak was seen only in regions where training takes place. The results suggest that freshly minted medical residents may need added supervision or extra lessons in dispensing meds safely. It also suggests that you use extra caution next month with the grill, on the shore, and at the fireworks.
A relaxing day at the beach. Then suddenly the peace is shattered by the sound of ships. It can sour your mood. Now a study in the journal Biology Letters finds that noisy ships make crabs crabby too. Researchers exposed different-sized shore crabs to either ship noise or ambient harbor noise. The crabs that contended with the annoying ship sounds had higher metabolic rates than did their companions, an indicator of stress. And the larger crabs were put out the most. Stressed crabs burn calories faster, which can stunt their growth in fisheries. Stressed wild crabs with increased appetites might need to travel to expand their feeding grounds, which raises their risk of running into predators. The research suggests that crabs aren't the only sea-dwelling species peeved by the noise either. Companies are exploring ways to design quieter ships in the hope of offering crabs and other marine life some peace and quiet.
You've heard about the canary in the coal mine and frogs as signals of environmental degradation. The latest animal to serve as a harbinger of toxic exposures to humans may be monkeys. That's according to research in the American Journal of Physical Anthropology. Macaques live in close quarters with people in parts of Nepal, so scientists thought that the monkeys might be, quote, sentinels for human lead exposure. Lead can have multiple deleterious health effects, from impairing neurological development to kidney, liver, and circulatory and respiratory problems. The research team wanted to avoid stressing the animals, so they took a few strands of hair from individuals living around a temple in Kathmandu. It's in a densely populated area that contains old lead batteries, flaking lead-based paint, and lead-contaminated soil, a byproduct of leaded gas. Lead levels varied in the macaques, but the highest concentrations were in the young. Like human children, young macaques tend to pick up objects and stick them in their mouths. Scientists say they'll next try to nail down whether macaque lead levels are predictive of lead poisoning in humans. The hope is that monitoring macaque lead can improve conditions for humans and monkeys alike.
More than half of all Americans carry smartphones. Smart watches and smart glasses may not be far behind. What's not all that smart are the rigid batteries that power our gadgets. But some may soon be replaced by ultra-thin, flexible batteries, sewn right into your clothes. Researchers built a prototype out of conductive, nickel-coated polyester fabric. They applied lithium compounds to create the anode and cathode, and separated them with a spandex-like material. The finished battery was just 0.5 millimeter thick, with a capacity of 510 milliampere hours per cubic inch, about a quarter that of the battery in an iPhone 5. And the tighter the knit, the higher the capacity. Of course, fabric wrinkles, but this battery can too. Even after being folded 5,500 times, the battery kept trucking. Thin foil batteries, on the other hand, took just 70 folds to become really foiled. The findings appear in the journal Nano Letters. You don't even have to disrobe to charge this wearable battery. Researchers tacked flexible solar cells to it so it can charge on the go. Might be just the thing to make polyester current again.